solving inequalities yesterday, strictly with addition and subtraction. So now we're going to throw in multiplication and division. And it's still the exact same thing, except we have one new rule. And I'm going to teach you why that rule actually works here. So for multiplication property of inequalities, and this is the same for division, okay, if both sides of an inequality are multiplied by a negative number, the inequality sign must be reversed. And the same applies for division. And we'll explain why. So let's look at being multiplied first. So if I look at my first one over here, 6 is less than 10. That's true. If I multiply both sides by a positive 2, I would get 12 is less than 20. That's still true, right? It still works. If you notice, my sign stays the same because I multiplied by a positive on both sides. Well, what happens when I multiply by a negative on both sides? If I had to multiply by negative 2 and a negative 2 here. Well, negative 2 times 6 is negative 12. 10 times negative 2 is negative 20. Well, negative 12 is actually greater than negative 20. So what do you notice about my sign? It gets reversed. So if you multiply or divide by negative on both sides, your sign has to switch. The sign has to switch. And we'll quickly look here at division. The same thing should apply for division. So if I divide by a positive, sign stays the same, right? 3 is still less than 5. So my sign stayed as less than. But if I do a negative, divide by a negative 2, now I have negative 3 is less than negative 5, which is not true. Negative 3 is actually greater. So anytime you multiply or divide by negatives on both sides, you have to switch your sign. Have to switch your sign. So let's take a look at it. Look at that number 1. 12k is greater than or equal to 60. Same rules apply. What are you doing to your variable? Well, I'm multiplying by 12 with my k. So the inverse of multiplying by 12 is dividing by 12. Whatever I do to the one side of the sign, I do to the other side of the sign. 12's cancel. I'm left with k is greater than or equal to 5. And it doesn't say to graph or anything now, so I can just go ahead, box that answer in. Look at number 2. Negative 8 times p, negative 8p is less than 96. Well, what am I doing to p? I'm multiplying by negative 8. The inverse is divide by negative 8. Whatever I do to one side, I do to the other. What do you notice right now? I'm dividing by a negative on both sides. So those cancel. I'm left with p. So what do we say when we divide by a negative on both sides? Our sign needs to switch. It needs to reverse. And 96 divided by negative 8 gives me negative 12. So if you divide or multiply by a negative on both sides, the sign reverses. That's the only new rule to this from yesterday. Looking at number 1 here. I have negative n over 6 is less than or equal to 8. I'm going to write this just a little bit bigger here. Over 6 is less than or equal to 8. So really, I'm dividing by 6, and if I think about it, I'm actually dividing by a negative 6, because I want to get rid of that negative sign. So the inverse of divided by a negative 6 is multiplying by a negative 6. I really just do that to get rid of the negative, because I want to get a positive in. And whatever I do to one side, I do to the other. Got to multiply by a negative 6. So my 6's cancel here, and a negative times a negative gives me a positive. It is less, oh, wait a second. I'm multiplying by a negative on both sides, so what happens to my sign? It flips, it gets reversed. And 8 times negative 6 is negative 48. So don't forget to do that. Looking at number 2, I have 1/5 times n is greater than negative 3. Well, the inverse of multiplying by 1/5 is dividing by 1/5, but we never actually divide fractions, right? We always change the multiplication. We multiply by the reciprocal. So I'm really going to multiply by 5 over 1 to cancel that 1/5. Whatever I do to one side, I do to the other. And 5 over 1 is just 5. I can simplify that. So these guys cancel. I have m. Well, I have negative 3 times 5. Does my sign flip here? Some people say yes, because I have a negative. But if you notice, what did I do to both sides? I multiplied by a positive number, didn't I? I multiplied by a positive number, not by a negative on both sides. So you got to look at whatever you did at both sides. So since I multiplied by a positive, my sign stays the same. And negative 3 times 5 is negative 15. So look at the difference between these two problems. In the left one, I multiplied by a negative on both sides. So whatever you do to both sides. Where over here on the right, I multiplied by a positive. So that's why my sign reversed on the left and stayed the same on the right. So it's whatever you do to both sides. That's the most important key here. Lastly, same thing as yesterday. It helps me be able to write an inequality for our situation. So Matthew walks at a rate of 3/4 miles per hour. He knows that it is at least 9 miles to Onyx Lake. How long will it take Matthew to get there? Well, first of all, I have a rate, I have a distance, and I'm looking for a time. So distance, rates, and times, that's our dirt formula. So distance equals rate times time. And we're going to come up with an inequality, so we're going to switch this equal symbol to an inequality. So I know my distance is 9 miles, and I know my rate is 3/4. I'm looking for t, so I'm going to leave it as t. Well, if I think about this, it says he walks at a rate of 3/4 miles per hour. He knows that it is at least 9 miles to Onyx Lake. At least 9 miles to Onyx Lake. So my distance could be more than that, couldn't it? So my distance right here could be more than 9 miles. It's at least 9 miles. So if I think about it, this right side could be greater than that. And it says at least, so that means it could also be exactly 9. So I got to put my equal to with that. And look, it might seem kind of confusing. If I flipped it around, if I put my 9 on the right side, this might help. 3/4 t. So a rate times a time here. I got a rate times a time on the left. That gives me a distance. I'm saying this distance right here, okay, could be at least 9 miles. So it's got to be, could be bigger than 9 miles, can't be less, and it could be exactly 9. So that might help if you look at it that way. So there's my inequality. Either way, either or, right? I just flipped them around. And then it states, how long will it take Matthew to get there? Well, just pick one of them and solve. I'll pick this one on the right. 3/4 t is greater than or equal to 9. And you're multiplying by 3/4, so divide by 3/4, which we actually multiply by the reciprocal. Whatever you do to one side, you do to the other. That's gone. I'm up to t is greater than or equal to, it's really 9/1. We can cross cancel here. 1 and 3. And 3 times 4 is 12, so 12/1. So it's got to take at least t is greater than or equal to 12, what we got, hours. 12 hours, because miles per hour. That's how I know where my label is, miles per hour. So 12 hours. So just follow that one rule. If you multiply or divide by a negative on both sides, the sign gets reversed.